Hello, and today's purpose of the day is I can write a polynomial in standard form, find its degree, and classify polynomials. Determine if the following problems are a monomial. Explain your reasoning. We covered this a few lessons ago, but this will help us as we classify polynomials today. So let's look at the first example, 14a squared b plus x. This would not be considered a monomial because of the addition symbol. (18a to the 6 d squared divided by c cubed). This would also not be a monomial because division of a variable. Cannot have division of a variable. (25.5). This would be a monomial, and to classify it or to explain why it's a monomial, we could say it's a constant. And a constant, if you recall, is a real number. Okay, 24a cubed y to the 9th z. This would be a monomial because it's a product of numbers and variables and satisfies all requirements. So I can say, yes, product of numbers or a number and variables. Could also say satisfies all requirements. Okay, an x minus 14x cubed. This would not be a monomial, and because of the subtraction sign. So again, just recapping from the beginning of chapter 7 about monomials, and this will help us again today as we classify polynomials. Let's go over a couple new definitions. Binomial. This is the sum of two monomials. So for example, a binomial could look like 5x plus 3 or even 2y minus 3x. It's separated with an addition or a subtraction symbol. A trinomial, the sum of three monomials. And so an example of a trinomial could be 5x plus 3y minus 4. And when I say sum, that could also mean, the difference. You could add a negative. And lastly, polynomial, the sum of more than three monomials. So anything that's more than three. So 4, 5, 6 could have however many terms. So if I give an example, we could say 2x plus y minus 2 plus 2x squared. So all different terms. And when I say different terms, that means that all the variables or the exponents on the variables are different, so we cannot combine any like terms, and each term is in itself separate. So now let's take a look at each expression and determine if it's a polynomial, and then if it is a polynomial, we'll classify it even further, whether it's a monomial, binomial, or a trinomial. So let's look at the first example, 4y minus 10ab. This would be a polynomial, and if we classify it even further, it has two terms, and the two terms is broken up because of the subtraction sign, so this would be called a binomial. Negative 4.35. This would be a polynomial, and to classify it even further, it would be a monomial. And if we even wanted to be more specific, we could say it's a constant because it's just a real number. 5b to the negative 4th plus 8c. This would not be a polynomial because it's breaking a rule of having a negative exponent, so it would not be a monomial, binomial, or a trinomial. And last, we see here 7x cubed plus 4x plus x plus 5. Be careful here. If we look closer, we can even combine the 4x and x, and that gives me 5x. So this is a polynomial, but to classify it even further, it would be a trinomial because of three terms. Now, sometimes we get mixed up and we don't think to combine the like terms, but we have to combine like terms first and then see what type of polynomial we have. So again, polynomial is the overall terms that we're looking at. Many terms is what polynomial means. And so if we have a polynomial, we can perhaps classify it even further as a monomial, binomial, or trinomial. And then if that polynomial has more than 3 terms, that would be just classified as a polynomial. So anything with more than 3 terms would be a polynomial. Now we are going to look at the degree of a monomial. So the degree of a monomial is the sum of the exponents of all of its variables. A non-zero constant has degree 0, and 0 has no degree. So let's look at that first bullet point, sum of the exponents of all its variables. So if I have a monomial that is 8x cubed y squared, let's say z, and that degree, so I'm going to add up all of the exponents, which would be 3 plus 2, and then this has a 1, and 3 plus 2 plus 1 would be a degree of 6 here. So I add up all the variables I add up all the exponents of all of the variables of that monomial. A non-zero constant, again, has degree 0. So for an example here, if I have just the plain number 5, that has a degree of 0. And the last bullet point, 0 has no degree, just means 0 has no degree. Now, for the degree of a polynomial, this is a little bit different. We need the greatest degree of any term in the polynomial. To find the degree, we add the exponents in each term, similar to the degree of a monomial. And see page 424 of your textbook for the names of polynomials, which I have listed here in the reference table that we'll come back to often. So, for example, if we want to find the degree of a polynomial, let's say our polynomial is 3x squared y plus, let's fix that y, plus 7z plus 8x squared y squared z squared. So I need to find the degree of this. So the first term here, this degree would be 2 plus 1, so that would be 3. This 7z would be 1 because z has an exponent of 1 with it. And then this last term would be 2, 4, 6. So the degree of this entire polynomial would be the greatest degree of the terms here, which would be 6. So the degree of this polynomial would be 6. Now, if we look at the table here to classify degrees, if we have a degree of 0, we call that a constant. And again, that would be a plain number. So up here, as we did 5, that had a degree of 0, we would call that constant. If we have a degree of 1, we call that linear. And if you recall from algebra, you graphed a lot of linear equations, which was in the form of y equals mx plus b. So what was the exponent on x? Typically it was 1. Quadratic is when we have a degree of 2. Cubic is when we have a degree of 3. Quartic is when we have a degree of 4. Quintic when there's a degree of 5. And if we have 6th degree or more, we would just call that the 6th degree, 7th degree, and so on. So we only give unique names and definitions for degrees 0 through 5. So let's go through a few examples and classify each polynomial according to its degree and number of terms. So number 1, 5x minus 2x squared plus 6. So this here, we see the largest degree. This would be 1, this would be 2, and this would be a degree of 0. So the largest degree here of this polynomial would be 2. So the degree is 2. So if we go back to that table, that was quadratic. So because the degree is 2, we call it a quadratic. And then how many terms does it have? It has 1, 2, 3 terms. So it is a quadratic trinomial. So again, we classified it by its degree and its number of terms. And so this would be called a quadratic trinomial. Number 2, right below, here the degree, this has a degree of 0, this has a degree of 4. So again, the largest degree of the terms here would be 4. So for degree of 4, and again, if we look at that table, Soon we'll start having these memorized. This is a quartic, and then it has two terms, 1 and 2, so it is a binomial. So a quartic binomial. Number 3, 12g cubed. So the degree is 3, so that's cubic. And then it's only one term here, so that is just a monomial. So a cubic monomial. Number 4, so the largest degree I see here is 5. So with the degree of 5, that's quintic. And then how many terms are there? There's 1, 2, 3, 4. So again, if you can recall, anything that has more than 3 terms, so 4 or more, would be just considered a polynomial. So this is a quintic polynomial. So we will see polynomials written in standard form. And standard form means written with terms in order from greatest degree to least degree. So here's an example in standard form. 4x cubed minus 5x squared. That looks like there's just a spacing issue. So that's 5x squared plus 2x plus 7. So if you can see, I go in order from largest degree down to, from greatest degree to smallest degree, to least degree. So this is a degree of 3, 2, 1, and 0. And then a couple more things we'll identify is the leading coefficient, and that is just the first coefficient or first number that's in front of your first term. So when you figure out the greatest degree, you put that in front, and then the number that's in front of that, leading that term, is called the leading coefficient. And then the greatest degree here of this polynomial is 3. So the degree of this is 3. So many times you'll see standard form, write a polynomial in standard form, and this will help identify some key pieces. Again, the leading coefficient and the greatest degree. So to get practice with writing each polynomial in standard form, giving the leading coefficient and degree, let's go through 3 examples. So here in number 1, I know the largest degree here will be 3 if I add up the x and the y squared. So I'll write 8xy squared plus 6xy would come second because that has a degree of 2. And then plus 5y plus 12. Leading coefficient would be 8, and then the degree would be 3. So we have this in standard form, identified a couple key points, and let's take a look at number 2. 9x squared plus 3x to the 6th minus 4x. Well, the 3x to the 6th would come first because that's the largest degree. Then 9x squared minus 4x. The leading coefficient, again, that is the first number in front, would be 3, and then the degree would be 6. Last one, number 3, I see I have t to the 5th, that will come first, plus 3t squared, plus 12t, minus 6. And the leading coefficient in front of t to the 5th is a 1. Can't forget about that there's a 1 in front. And then the degree here is 5. Thank you for listening. Have a great day. Bye.